Hello, this must be Mrs. Hanafi's Period 2 Calculus class. The last period just came in, I must say. They were quite a pain. You guys will be better, right? I can tell. We haven't met yet, have we? I'm Professor Grimshaw. I am the arithmancy professor at Hogwarts. Today, we will be learning about parametric equations and their use against the dark arts. Let's get started. Parametric equations serve as a powerful tool to describe the position, velocity, and acceleration of objects as functions of time. By expressing coordinates as functions of a parameter, such as time, we gain insight into the dynamic behavior of magical entities. The position vector describes where something is, the velocity vector, is obtained by deriving the position vector and the acceleration from the velocity. Likewise, the position vector can be gained by integrating the velocity vector and adding a constant, and so on.
Professor, do you see that?
Ah! Shut the front door! I was struck by some possessed broom. I've fallen and I can't get up. Ms. Hanafi's Period 2 class. You are the only hope left for Hogwarts. Work with Ron and Hermione to solve parametric equations and save us all.
Hello, mate. My name's Ron Weasley. You probably know me as one of Harry's friends. Lovely old chap he is. Anyways, in order to solve this ginormous problem Hogwarts is dealing with, let's learn the basics that we need. I, personally, am an accomplished Hogwarts last year student. Here, say we are given the equations x equals t squared and y equals t plus 1. Try and draw the graph. Pause now.
Ron, that's too basic for our friends. Here's a challenge. Can you find the tangent line for these parametric equations? Fine. I'll give you a hint. The equation to find the tangent line is di over dx equals di over dt over dx over dt. Try it out. X equals t squared and y equals t cubed. Minus 3t. Pause right now. Brilliant. Let's see what you've got, eh? To take the second derivative, the steps are quite similar. Refer to your worksheet for the formula. Use the equations y equals t cubed minus 5t and x equals t cubed plus 3t squared. Is the curve concave up or down?
Oh, blimey, fiddle my sticks! Is that Harry's broom? Enough with the lesson, Hermione. We need to go save Hogwarts. I bet he who must not be named sent that broom to sabotage us all.
I don't see it. Ron? Anyways, friends, we were learning how to find horizontal and vertical tangent lines. The curve C has a horizontal tangent line when di over dx equals 0 or when di over dt equals 0 and dx over dt does not equal 0. Find the horizontal tangent line given y equals t cubed minus 3t and y equals t cubed minus 3t. Pause now.
Oi, I'm chuffed to bits. How jolly. Ho, ho, ho. Look what I've found. This broomstick looks rather fun. Why don't I go on a ride? Bet you can't catch me.
Rubbish. I'm knackered. Quick, friends, I have a feeling we'll need this equation. The equation to find distance of curve, let's say C, is L equals the integral from a to b of square root dx over dt squared 2 plus di over dt squared. Keep that in mind.
Sorry, friends. I got a bit carried away. The darn broomstick flew in there. Anyways, we were talking about particle motion. The term vector indicates both magnitude and direction. Here is an example of vector notation. Notice the brackets. Additionally, Velocity vector is given by taking the derivative of the position vector, or second derivative for acceleration vector.
Speed of the particle is represented by the formula speed equals rad dx over dt squared plus dy over dt squared. Try this problem on your worksheet. X equals 4t cubed plus 4t and y equals 6t squared minus 2 given the point 0,1. What's the speed? I believe in you, friends.
Ooh, you're doing great, friends. Here's the final idea we're learning. We need to find the x-coordinate of the position of the particle at time t equals 3, given dx over dt equals natural log t plus 1. At time t equals 1, the particle position is 2,5. Here's a hint. Use FTC. Hermione, friends, is that who I think that is?
Haha, young Hogwarts friends. I can tell that you have not been doing your homework. Ron and Hermione, I can tell you still haven't learned. Oh, and some new friends, eh? I hexed Harry's broomstick to lead you here.
Time's ticking, friends. That's it. Who avada kedavra? Ra-ha!
Expecto Patronum!
Congrats, Ms. Hanafi's period 2. You have done a noble deed today. Never in my 2,000 years of teaching have I seen such brave, bold students. Fiddly knackers. It is time to reward our brave houses. Pause now.
See you again soon.